Alright guys, so today we're going to go through the review together. When I try and do it at the board, I can't get through it, so I'm going to put it on here so those of you who want to do it can go through the review with me, essentially. Or at least listen to me do it so you can kind of learn a little bit more of what to do. So this first question, what is an arc? Well, an arc is just a piece of the circumference. Left my answer key over here on the coffee table. Alright, what about a sector? Well, that's just a piece of the area. What about the formula for circumference? Well, there's two different formulas for circumference. We have 2 pi r, or we know that 2 and r, so just multiplying those two together, 2 times r gives me d, so c is d, or diameter times pi. So either way, we need some form of the diameter. Either we take our radius and multiply by 2, and then multiply by pi, or we just take our diameter times pi. What about the formula for area? Well, this guy is area is equal to pi r squared. So in that case, we have to take our radius and we have to multiply it by itself. We have to square it out in order for it to work. That's what gives us that extra bit of stuff that we need. All right, let's go ahead and determine the arc based on the given angle. So an arc is a piece of my circumference. The circumference is all the way around my circle. So if we're given the angle DXF, that creates an arc DF. What about angle WPL? Well, that creates arc WL. This one is a little bit more tricky. We have FVX. So there's kind of two arcs created here. We could say we have FT, or we could say, because it's a major arc, because it's technically a semicircle, it is equal to 180. I like to use 3 letters on that one and say FDT or FQT. So I just really prefer to not have this one, because when you're dealing, oh, you can't see that, can you? Oh, sorry, I forgot I'm there. There you go. I would prefer to not have the FT because it is considered a semicircle, and a semicircle is basically a major arc. When we deal with major arcs, we need 3 letters. Alright, we have BPM. So that one, because it's not a whole 180 degrees, we can use our BM. Unless you're wanting to refer to this way around the circle, then it would be BWM. There's 2 different arcs that we're talking about, essentially, in this one. All right, determine the angle given the arc. So if I'm looking at QT, what angle creates that? Well, angle QXT. GB, that one's going to be angle GPB. Q, F to D. So we have to go from Q, we have to hit F, and we have to hit D. So we're going to have that big major arc there, but that angle is QXD. Again, we have another major arc, so we need G to L, so we're going to have to go down, so GL to W. So that's angle, ooh, that's a funny angle today. GLW. It's almost like glow, but not. Alright, on these ones we're going to go ahead and determine the circumference. So if you recall from slide number 1, what is the formula of the circumference? We either need 2 pi r or diameter times pi. So we have the radius, so if we multiply that by 2, we have 10. So we have 10 pi, which when we multiply that in our calculators will give us 31.42 meters. Now, it's a length, it's just part of it. So it's not squared. We're not having the area, we're just determining all the way around. So it's just in meters. Ooh, my heartburn is killing me today. Number 14 right next door. We need my diameter, which we already have, so it's going to be 20 pi. When I plug that in my calculator, I get 62.83 centimeters. Haha, I put my 3 and my E, my C together. There we go. This one we have my radius of 15, so we know my diameter is 30. So I have 30 times pi, which would give me 94.25 feet. Again, we have our whole radius, so we know, the whole diameter, so we know it's 14 times pi, which will give me 43.98 inches. These last two were just given either the diameter or the radius. So if my diameter is 4, it's just going to be 4 pi, which is 12.57 inches. This one we just have our radius, so we have to square it. Or not square it, we have to multiply by 2, so it gives me 12 pi, which gives me 38 feet. Now, the reason that one's just 38 is because I had to double check myself, I forgot. I get 37 point, should be 37, I can't round. I couldn't round this morning, apparently. It should give me 37.699, which will give me 37.7 feet. I don't know why I didn't round that correctly in my notes. It's on there now. All right, next ones, we're finding the area. So when I find the area, if I go back, we're going to use this purple formula, so pi r squared. So we have my r, because remember we need radius in this case, so I have pi r squared. We can plug it into the calculator that way. And that gives me 78.54 meters squared. And number 20, I need my radius. So my r here would be 10. So I have pi times 10 squared, which should give me 314.16 centimeters squared. In this case, I need to square my 15. I have my radius, so we're all good. So we have pi times 15 squared, which is 706.86 feet squared. So I'm going to fix that as a 0, not a 6. I need my radius in this next one, so that's going to be 7. So I need pi times 7 squared, which is 153.94 inches. quantity squared. Because remember, we're finding area, so all of these are squared. If my diameter is 4, my radius is 2, so I have pi times 2 squared, which gives me 12.57 inches squared. And in this one, I have pi times 6 squared, which gives me 113.10 feet squared. There you go. I'm sorry, guys. I'm trying with the video. It's new. Alright, in these next ones, we're going to find the length of the Bolden arc. So that means we need to use our skills. And we're going to find a piece of, my perimeter. So when I do that, I'm going to have whatever that degree is. So in this case, 215. So I'm going to take 215 divided by 360 times the formula for circumference. So that's 2 pi r. So in this case, my r is 5. So I'm going to multiply by 2 and I have 10. So I'm going to plug that whole thing in the calculator. Remember to do that in the calculator. I'm going to rewrite it so you can see it in the calculator way. So it's going to be 215 divided by 360 times 10 pi. Which gives me 18.76 feet. Number 26 will be 90 degrees out of 360 times 3 times 2, which gives me 6 pi. Which in the end gives me 4.71 inches, so not very long, which makes kind of sense. 27, we are dealing with 165 out of 360 times 16 pi, which is 23.04 centimeters. And 28, I have 145 out of 360 times 12 pi. This gives me 15.18 centimeters. And that last one, the area of the shaded region. So this is very similar to the last section. In the last section, we used in the second part our circumference formula. In the second part in this one, we're going to use our area because since we're finding the area of a piece. So in this first one, I have 215 out of 360. That's going to be multiplied by pi r squared. So pi 5 squared. Which gives me 46.91 feet squared. And this one I'm going to have 90 over 360 times pi 3 squared, which would be 7.07 inches squared. On 31, I have 165 out of 360 times, now I need my radius. This one's giving me the diameter, so my radius would be 8. So pi 8 squared, not 16, which gives me, oops. Oh, what did I do? I erased too much. Hold on, let me fix it. Go back to the regular size. So when I multiply that whole caboodle out, I get 92.15 centimeters squared. And that last one, 145 out of 360 times pi 6 squared, which gives me 45.55 centimeters squared. That's all I got. I hope if you have any questions, please ask me.